Welcome to this video, friends. We're going to go on a graphical journey of doing a limit. So this is again a video for people who love a lot of graphing, not just simple manipulation. So I'm going to do the limit as x goes to 0 from the right side of x times ln of x. So again, I'm going to walk you through stages and graphs. So if you graph the original, you're going to graph the x separately from the ln x. Why would you do that? Because you want to see what the relationship is that applies between them. So you graph x and you want to graph ln of x separately. So x and ln of x. You've graphed those in pre-calc. Now look what happens very carefully at this stage. It's telling us that the following holds. This is going to 0, this is going towards negative infinity. So this is telling us the pattern is 0 times negative infinity. That's the pattern. So in other words, it's not set up for L'Hopital's rule because it's got this weird situation. So what we are going to do is make one move. We're going to take the limit as x goes to 0 from the right side here of ln of x divided by 1 over x. How can we know to do this? Why would we do this? So now we got to know our fractions. Think about the way fractions work. When you do 1/2 divided by 1/3, or even just make it a 1 up there, or a 5 or something. 5 divided by 1/3. We use keep, change, flip. We learned that in algebra, right? So we're going to have 5 times in the 1/3 becomes 3 over 1. So in other words, it's the same as just 5 times 3, is it not? Think about it. So 5 times 3 is the same as 5 divided by 1/3, which means x times ln of x is exactly the same as ln of x divided by 1 over x. But does this change something? Like, does it give us a benefit? Does it give us something? Well, graph the results separately. You want to graph separate pieces. So now you have ln of x on top. That's the green, right? And then I'm going to put on the bottom 1 over x. So you see what this looks like now? Why is this better for L'Hopital's? Look, this is better because the following applies. Let me just move this box. When x approaches 0 from the right side, this is going towards positive infinity. This is going towards negative infinity. So simply by using a trick of fractions, we are able to make this into a form that works better with L'Hopital's. This is positive infinity over here now, and this is what? Negative infinity, like that. Now we have the right form for L'Hopital's. Again, contrast this with here, where an x goes to 0, this is going to 0, and this is going towards negative infinity. So now it's in the right form for L'Hopital's, just differentiate the top and the bottom independently. So I'm going to have the limit as x goes to 0 from the right side. The derivative of ln of x on top there is 1 over x. The derivative of 1 over x on the bottom is negative 1 over x squared. And you're saying to yourself, has something happened? What's the graphical impact of this? Well, let's see. Have you changed anything? So you graph 1 over x, the top separately. You see what it looks like? Then you're going to zoom in at some point. Negative 1 over x squared this way. And then zoom in again to the relevant pieces, the ones where x looks like this. And everything has been preserved. When x goes to 0 from the right side, this goes towards positive infinity, this is going towards negative infinity. It's good for L'Hopital's. It's still some kind of infinity on this side and a negative infinity on this side. Now, algebra. A little bit of algebra. I'll do that down below. We're going to simplify the fraction. So remember, we have the limit as x goes to 0 from the right side of that, what was it there, 1 over x divided by negative 1 over x squared. So that's going to be the limit as x goes to 0 from the right side. And you're going to flip it. So remember, keep, change, flip, algebra. And the other one is negative x squared, like that. When you do keep, change, flip, if you like, you can put this over a 1 if it helps you. So it looks like this. So it's the limit as x goes to 0 from the right side. And then you cancel, but you have to be very careful when you're canceling. This assumes that what? X is not equal to 0. Because you have x squared divided by x. When x is 0, this is not valid. But that's okay because we're doing the limit as x approaches 0 from the right side, not when it's equal to it. So you're going to have now negative x squared divided by x is negative x. So look, from all of these manipulations, what's left over? Negative x is just a function that looks like how? Zoom in around here. It's just a function that looks like this. It's a straight line. So now, it's incredible, right, how this all works out. It's just negative 0, which is 0. The value of the limit is 0, okay? So this is how you can use multiple graphs to help you reason through things at a deeper level, hopefully, than you might do otherwise. So bad for L'Hopital's, good for L'Hopital's. At this stage, still good for L'Hopital's. And then it becomes something where you can just plug in direct substitution. If you like these types of videos, please be sure to subscribe, to like. Thank you so much for watching. Please check out the other videos on my channel. An important aspect of, I think, being a human being in general is to always have a flexible mind and just a deep and abiding desire to learn. How do you get a deep and abiding desire to learn? If you ask the universe, however you conceive of it, however you conceive of God or the creator or the uncreated eternal source of everything, just feel this is what I do. Every day I say a prayer, not a religious one, but just a kind of prayer meant to evoke like a sense of deep connection with the entire universe. So I don't feel separate from it. And because the universe is so vast, it tells me, you know what? I can always learn more. I can always learn more because in the process I'm learning about myself because I'm part of it.